Once I get rid of David, all the integrals, then I need my plus.
Oh, because that's what I asked initially.
Oh, is it really? I'm sorry.
No, that's fine.
Anybody?
Really?
Are we doing the use of?
I'm saying give me the evaluation integral.
Natural log or something?
Natural log of
Stuff.
parentheses. What stuff? U squared plus U plus 1. Ay, ay, ay. Minus?
So can you actually do all of this in your head, like just from the beginning?
Yeah, I don't
Yeah.
see how you
Once you get used to the minus, it's really easy.
Alright.
I'm just slowing down for you, showing how easy that is. Minus 1/2 times.
Well,
I'll help you.
you
2 over. Did I mistake this class in my morning plans? The square root of 3. Tangent inverse.
Tan inverse.
2u plus 1 over root 3. Oh, David, it's your turn.
Wait, what?
Plus C.
And now you guys, I'm still not finished. I want to go back. Substitute, or if it's convenient, maybe combine these into a single log, etc., etc., etc.
Can we take a step back and?
Yes, we can.
Do-
Where you at?
Do we do a slow motion on the second one?
I thought it wasn't slow motion. On the second.
Yeah, well, not on your head, not on your head.
So from here to here.
Yeah.
Wouldn't you guys agree with this? Watch. Watch my blue pen. Call it Z. Isn't this?
Oh, so you did it.
DC? I did a Z sub.
A Z sub.
Anywhere else? Yikes. Yes.
Wasn't there a 3-out part to the integral, so shouldn't it have carried down to the second one and then those ones separated?
Are you saying I missed a coefficient?
Because you carried it out with the ln of the absolute ln of u minus 1, but then you dropped it and put the other one aside.
You know what, you guys? She's right. She's 100% right. Check this out. I really didn't catch that. I did take care of the 3 business with this natural log. Nice. It's just that this 3 should have been distributed with the next one. I'll slip it in. I'll cheat. And I'm sorry, now a little sloppy. You might want to go in and clean up coefficients. But you guys, can I stop so we can talk about other tactics? As a matter of fact, I think if you look at example number, where am I at? I can't read that.
4.
Look at how nasty that is. It's got different radicals in there. So if you guys don't mind, let me make the suggestion. I've got this interval. Maybe not a very common occurrence, but I think an example like this, I probably come into a substitution, letting u be equal to the square root or the cube root of x, whichever one makes more sense, or I can't, they're different. But you have to confess, square root of x is like x to the power of. Cube root of x is x to the power of. Well, how about 1/3? And the common denominator is, let's try that. Let's see if it works. Let's see if it helps. That means u to the 6 is equal to x. That means 6u to the 5th du is equal to dx. That means that this integral is equal to the integral of, okay, time to slow down, everybody. Another name for the first term downstairs, well, check this out. Take the square root of both sides. Don't I see that the square root of x is equal to u cubed? And trying to grab another name for the cube root of x, well, here's an x. If I take the cube root of both sides, doesn't that tell me the cube root of x is equal to u squared? Oh, did I miss something?
So how did you choose to do u to the 6, or the 6th root again? Why did you choose the 6th root?
You're not going to yell at me, are you?
No.
Back in the first grade, when I saw the fractions 1/2 and 1/3, 6 was just simply the common denominator.
not 3 anymore.
It's not 3 anymore, no. And by the way, I missed something, darn it. Another name for dx is 6 u to the 5th du. What's next? What's next?
Around u squared and cancel.
Yeah, pull out a u squared and cancel. What's next?
Well, you have a tangent sub that you could
well,
do.
I don't have a u squared plus 1 downstairs. It's just a u.
Oh, okay.
Funky form of 0.
Thank you. Your favorite number.
Yes. One plus 1 minus 1. No. What do I? Plus 1 minus 1.
Oh, isn't that beautiful? Somebody asked why. Well, check this out. Look at these two terms. I want a yes or no answer. Do you see a u plus 1 in there?
Yes.
Yes.
Good. Do you see a u plus 1 in there?
Yes.
Yes. Do you see a u plus 1?
Yes.
We're done. I think that gives me nothing more than 6 times the integral of, well, shoot, that fraction reduces down to,
U squared.
this one reduces down to,
Negative U.
this one reduces down to a,
1.
oh, I got a minus 1 left over, darn it. But that's okay. Piece of cake being anti-differentiate, isn't it? That's 6 times 1/3 u cubed minus 1/2 u squared plus u minus the natural log of u plus 1 in absolute values. I think that's slick. Well, the idea is slick. I guess it's not truly slick because, I don't know, maybe I should back substitute. Maybe there's some ways I can clean it up. It's just that I'm beating that clock in class today. If you don't mind, I'm not going to do that. You're yawning, sorry.
So, in your head, what's the answer to number 8? Or the final one on there? Can you do that in your head?
That's a delta. That's a delta. Sorry.
That's a delta?
Yeah.
You-
A lowercase delta, not an upper.
Lowercase delta?
Alpha, beta, gamma, delta.
Oh, so delta. Can you do that in your head?
I don't know. Let me see. Yeah. It's cosine cubed. That's the final answer. I didn't give you the coefficient up front, but it's just cosine cubed. It's that easy.
Cosine cubed of x?
What's that?
Cosine cubed of x?
Yeah, cosine cubed. You know, but it's just because the substitutions I make in there. You guys, I'm running out of time. You know, when I list these examples, alpha, beta, gamma, delta, I just made those up in such a way that I wanted you guys to see this. There's ways I can identify what technique I need to approach when I first look at an integral. And it is a case that in some of these examples I need to use multiple techniques. Look at my first example. When it comes to an integral to evaluate, now that you've got all these integration techniques, what are they? Substitution, integration by parts, trigonometric integrals, trigonometric substitutions, partial fraction decomposition, and now today the rationalizing substitutions. These are the integration techniques I've been giving you over the first few weeks of this summer course. We're finally at a point where I should be able to open up the book. I was horrified. I did it this morning. It didn't happen. There should be a nice section here that gives you a bunch of examples of integrals like these where it's your decision to what to apply as a technique. And so it appears to me that I'm going to have to go to my office today and type up some examples and post it in the homework page to give you more practice, since I don't think the book's doing enough.
So when the book talks about integration tables and asks you to
Yes.
solve things using tables, what does it mean by that?
It's sort of like my reduction formulas.
Is
Those
that-
are the table integrals. And so in the back of your book, there's like a couple pages where he's got standard types of integrals. You can use those tables to guide integrals. That back of the book is horribly limited. I got a book at home. It's this thick. Nothing but integration tables. So he's got extremely light list of trigonometric tables. What do you think, looking at the first, what's the first technique I should apply to any integral? What's the easiest technique?
Substitution.
Substitution. What's the most difficult technique to you?
partial fraction decomposition.
Is it really?
I don't.
I would have said, I would have said integration by parts. For me, integration by parts is typically the last one I apply. But I think with my first example, do you think a use of makes sense?
Yeah.
Yes.
Hugely makes sense. After all, letting u be the natural log of x simply gives you a derivative which is 1 over x in the x position. Can we not write? Doesn't that give the integral of u over root 1 minus u? du. What would you do next?
Evaluate.
Well, I got a radical. There are no sum or difference to squares, so maybe a rationalizing substitution.
Oh, I think.
You guys, I'm just playing chess. I'm just looking ahead. With my next example, what do you think?
Use up.
You know,
I'm gonna have to split.
that would actually work. But it doesn't change the fact that I could still straightaway apply note taking. And if you said u equals natural log of x, your next step is going to do what I'm doing even here. What's the relationship? What's the clean relationship between sine functions and x squared functions?
Integration of parts.
Thank you. Since there isn't any, give up integration by parts. What about down here?
Now when you have to go
I'm
through
not sure
what
if
you
I
just
have
went
x squared
through.
here, but there's no x squared.
Partial.
Only works with rational expressions, and that's not rational.
I meant.
Well, you have to make it rational and then
How?
u sub,
What kind of use them?
the one that you just did here.
Good.
Yeah.
So commit to rationalizing substitution. I clearly see that ends up with a rational expression. You're going to have to use partial fraction decomposition. Down here, clearly,
Trig sum.
trig sub. They're pretty bare.
Yep.
What section in the book combines everything? I know it's light, but.
None really. That's why I'm saying, David, I'm going to create some examples of my own. I'm going to post my homework page sometime this afternoon before I go home.
You're gonna do the rough.
What's
Oh,
that?
are you gonna do the answer as well?
Oh.
Just like the answer, not the actual process.
Okay. Can I talk homework?
Sure.
Excuse me. And then talk about the examples for a few minutes. Ay, ay, ay. Did I already sign 7.4?
Yeah.
Yep.
No, not really. Not all of it. So, in section 7.4. $60 through 65 all. Man, is that it? 1, 2, 3, 4, 5, 6 exercises. Jeepers.
This is 7.5, right?
No, this is 7.4. 60 through 65 all. Section 7.5. $21 through 32 all, but do not listen to the author. Do them all by hand.
What does the author tell you to do?
Use tables.
Okay.
I'm so unhappy with the rest. I give up. Like I said, I'll write my own today.
The rationalizing substitution is visible.
Yes, it is. And when I was being silly about did I sign 7.4,
Oh,
you said yes, and I said no, not yet. That's actually the second part of 7.4.
okay.
It's not really a big part. It's a very small section. You guys, I'm sorry if I failed to post exam solutions. I've had them all along. I just never get a chance today. I'll make sure I don't do a lot in the Math Center. I will also post a take-home quiz today. It's already typed up. It's already on my little, if I can find it, my little floppy thumb drive.
So
So check sometime today or this weekend.
what sections are going to be on the exam?
The exam, thank you. Officially, will cover 7.1 through 7.5, but also 7-6, which I'll cover on Monday.
Okay.
Also 7-6.
Not 7-7.
You know what, I can